Okay, we're back from break. This is still Tuesday the 19th. Assignment E, the next thing we're going to do on the handout, it's step B, create structural columns. So we want to load the pipe column family. Just so you know, in the Blackboard, I have a reading handout. If you go down to reading handouts here, that is loading a family from the library, structural column. And it kind of goes over the process of loading, and it goes to structural columns, steel, then you highlight the column, and then it shows how you can load certain types here. So that handout's there if you get kind of lost in the process of looking for something, but I'm going to go ahead and go to Insert, Load Family, and this is the out-of-the-box library, which is where it should default to take you. Go to Structural. Now, one thing on the content that comes with Revit out of the box that they're very good on is the structural elements. So we go to Structural Columns in Steel, and you'll notice they've got wide flange columns, they've got pipe columns. So we want pipe column. Once you highlight the family in a family like this and hit Open, you get this, which is called a types table. And if any of you who have used a steel manual, you know there's dozens of types, especially for wide flange columns or beams. So we want to go down there until we find the 4 extra strong, so pipe 4XS. And under the old nomenclature, it used to be like pipe schedule 40. So before I load that, I just want to show that this little template that we've been using here, if you go down to structural columns, which by the way are different than architectural columns, there's a pipe 4 schedule 40 and a pipe 6 schedule 80. Those are the old nomenclatures that the steel manual used to use for pipe columns. So if you load them now, go into structural columns, steel, the same family, pipe column, is still there, but the types table has different named types. So if we go to 4XS and we say, okay, we're just loading, you can highlight more than one if you want, like 4 standard and 4, there's a strong, there's an XXS, XS, and so on. I'll just load those 2 pipe 4s. Now it says you're trying to load the pipe column family, which already exists in this project. Now normally you only get this message when you have changed something about that family, like when I was trying to fix my doors last time I was trying to reload them. But you're not really changing the family in this case, you're just adding more types. So if I say overwrite the existing version, its parameter values, I'm not really modifying how the pipe looks, I'm just modifying the types. And if you go back down here, now I have pipe 4 standard and pipe 4XS, which are the new types. And if you look at 4XS, it shows its gauge is extra strong, the weight per foot is 15 pounds, area is 0.03 square foot, and the outside diameter is 4.5. The thickness is 4,328 of an inch thick. The inside diameter is slightly over 4 inches. So the 4 extra strong pipe is really quite a bit bigger than 4 inches outside diameter, but that's how they're listed in the steel manual. So now we're ready to place a structural column. Now you'll find that either in Home, under Column, Structural Column, or you'll also find it under Structure, Column, and Structural Column. Notice how the picture for the plain round column is structural. The one that looks more like a Doric column is architectural. And when you place an architectural column in the Home ribbon tab, it remembers it. If you go to Structure, it always wants to take you back to structural column, which makes sense. So I'm just going to go to Structure, and I'm going to click on Column, and now I get to pick my family and type. So I want the pipe 4XS. Now I need to be in my basement plan view, so I got to go back down to my Work L0 existing architectural plan view. And let's try it again. 4XS. Now, when you're placing a column, similarly to what happens when you're placing a wall, you've got a height that's defined by the base and base extension and so on. So in this case, I just want to first click top of footing, second click 3D snapping. I don't want to do 3D snapping here. So I want my top of footing to be the elevation of the bottom of this column. So notice when you hover over the intersection of two grid lines, they turn blue, and you can snap to that intersection, and it places your column. Not quite sure. Oh, I think I messed it up when I started in an elevation view. So I'm going to try that again. Yeah, I'm not used to this first click, second click stuff.
When I'm trying to place mine, does mine got dark?
I think I've gotten off on some kind of weird tangent here.
Okay.
Yeah. Okay. This time I'm going to try going to home structural column. Yeah, it's wanting me to put a slanted. Oh, here's my problem. On the ribbon, I've got slanted column instead of vertical column. And I don't usually use slanted columns. So if you go back into the structural column command, make sure you're on vertical column. And there we go. So it assumes that it's starting at the level that you're on, which in this case is level 0. And it has a height. And it goes up to the first floor by default. So I'm just going to let it do that, and I'm going to come back and fix that in a minute. So make sure that both grid lines light up before you click to place the column. Now if we go to a 3D view, we can see what's really going on. I'm just going to slice away this west wall of the building with my section box. In fact, I'm going to get real close to the columns, up close and personal with Michelle Pfeiffer and Robert Redford. Okay. So now you can see that the top of the column goes literally to the first floor level, which we're not going to want ultimately, and we want the base to come down to top of footing. So I'm going to select both columns in this 3D view. I'm going to change the base level now that I've placed them to top of footing, which extended them now so that the bottom of the column is right at the underside of the floor slab. So now let's go ahead and do our column footing. So I'm going to go back to the top of footing plan this time. And I'm going to go to Structure and Foundation, Isolated Footing. Remember we did wall footings in Assignment B. This time we're going to do isolated footings. And there's a component family that's used for isolated footings as opposed to the wall footing, which is a system family. System families can't be saved, but component families can be and need to be loaded. So I'm going to say, yes, I'm going to load that out of Foundations, Structural Foundations, and I want Footing Rectangular, and Open loads that. And I want my column, my footing to be 48 by 48 by 12. Well, there's not a type to match that, but I can build a new type on the fly while I'm in the command. I just hit Edit Type and Duplicate. And now I'm going to give it a new name, 48 inch by 48 inch by 12 inch. I don't need it 18 inches thick, just 12 inches. So then after I name it, don't forget you got to change its width and length and thickness to match what it says it is. So 4 feet and 1 foot. So now the name matches the properties. And I can say OK. So now when I drag that around and I click to the intersection like that, it should place the footing right below the column. Now in this plan I don't see it because I've got a floor slab in my way. And if I go to wireframe, I should be able to see it. There they are. If I go back to my 3D view, I should be able to see it. And there they are there. Now one kind of funny thing that happens is if I say I want to lower the bottom of my column, I could say instead of base level top of footing offset 0, I'm going to say -2 feet below top of footing. And it says an attached structural foundation will be moved to the bottom of the column. So now that it's there, if you drop the base of the column, it will drop the footing along with it. Makes sense. The column should stay attached to the footing. So I could do that with this one. I could say, let's offset that one negative 1 foot below top of footing. It says the same message. Well, you don't really attach the bottom of something to the... you can attach the top of the column to the underside of a beam or a floor, but you can't attach the base of the column to the bottom floor. Are you talking about the top of the column?
Yeah, top.
Yeah. Actually, we're going to put a beam in there, and then we'll attach the top of the columns to the underside of the beam. And so then where the beam is depends on one of two ways that we could frame this basement. So that's our next challenge, and that's the step D here. So we're good on footings. We're good on columns with the exception of what Charles brought up, and that is the top of the column still needs to be set. So we're going to actually draw ourselves a detail tonight. So let's go to our plan view. Work L0 existing. I'm going to close all my other views here. So I'm going to go to the little close hidden right here. I'm down to just one view. Now, do I have any sections yet? Has anybody cut a section? We have longitudinal looking east through center. Well, that's not looking the right direction to see the columns and the beam that I'm going to place. I want to slice through the beam. So I'm going to cut another section view. Now let me make sure that VG says that I'm going to see sections here, because if I have sections turned off, I won't see them. Yeah, they're turned on. So I'm going to say view, section, building section, and I'm going to cut it just south of one of the columns, and then I'm going to right click and go to that view. What's wrong with this view? It shows the column like a little stick figure. Well, that's because it's the level of detail, which is kind of similar to scale, but in this case, that's what controls it. So if we go to coarse, you only see the stick figure. If you go to fine, then you actually see the outside diameter of the column. Now, the next thing we have to do is actually create a beam there. But if you look at this floor, I'm going to bump my scale up to a 1/4 inch scale. I went south of grid line 2 looking north. Because I want to be cutting through this beam. Now we haven't placed our beam yet, but we're about to. So to place the beam, we want a structural beam that supports the first floor. Well, if we look at the floor structure, edit the type, edit the structure, preview it, we've got a layer of wood flooring on top, finished wood. Then we've got our wood sheathing, plywood, which again is not really historically accurate to what the house would have been, but and then we've got our joists at 9 1/4. They're 2 by 10 joists. So our beam can either go right below the plywood, in which case the joist would have to frame into either side of the beam, and we'd have to put blocking. The advantage of that is then you'd have more head clearance in your basement. Or the easier way to build it would be to put the beam under all these joists and let the joist just bear on top of the beam with like a 2 by piece of wood blocking on top of the beam. So I'm going to give you two options on how to do this detail. And I'm going to do it the way I think is probably easier to build, which is dropping it below with the blocking. But let's place our beam. So now, since it's supporting the first floor, and for those of you who aren't architects or structural engineers, there's this disagreement between architects and structural engineers as to what constitutes a first floor plan. An architect wants to show the walls going up from the first floor on the first floor plan. Structural engineer for a first floor framing plan actually wants to show the columns that support below the first floor, and they don't really care about the walls that are going up because they only care about the structure that supports it and then any structure that bears on it. So we're going to go and make ourselves a first floor framing plan. So we can duplicate level 1 existing architectural plan, and then we want to change it, and I'm going to rename that, and I'm going to call it work level 1 existing framing. Now I didn't actually do this in the handout, I just want to kind of show how you can do this. Now if I change this from architectural in the views discipline to structural, then I actually don't see any walls. Well, the walls have to be bearing to show up in a structural plan. So if I go back and I select, I can do the tab trick and tab and select all my brick walls, and then there's a property of the wall that says structural. If you check it and make it bearing, then when you apply that property, your framing plan will actually show those walls now. Now you normally wouldn't show non-structural walls, but you also wouldn't really want to show doors on a framing plan. So I'm going to go to VG and I'm going to turn off my doors. Now, I want to place a beam here, and normally a framing plan is set so that the view range is cut not 4 feet above the floor, but maybe right at 0, and it drops down maybe 2 feet below the floor you're on to look and see what happens below. I'm going to do negative 3 feet. So now if I place a beam in there, Rabbit knows, okay, I'm a structural engineer, I'm placing a beam. Now I'm going to go ahead and do it in the regular architectural working floor plan because that's how I show it in the handout. But if we go to structure now and beam, don't worry about loading a tag. You can say, no, I don't want to put tags on this beam because I'm not really doing a structural plan. The only beams that are loaded are dimensional lumber and LVLs and plywood web joists. I don't see anything else in here, so I'm going to go on to load family right off of the... When you're in the middle of a command to place something, if you don't have the family you want, you can go right in and load it. There's usually this load family button, so I'm going to do that. Just like we did with the structural column and the structural foundation, I'm going to go back to structural framing, which is where beams are, and then steel. And I only need the W8 by 35. The family is W wide flange. You open that. Again, you get another types table. W8 by 35. I could load another one just for the fun of it, so I have 2 types. So now I'm still in the beam command, and I can say, okay, I want to pick the wide flange W8 by 35. So bottom line, before I place it, I want its reference level to be first floor, and I actually want its I'm going to draw it right on top of this grid line from that wall straight on through to that wall. Now that's telling me that I can't see it. Yeah, I actually want center line of wall to center line of wall. And I got a little message that I can't see it, but I bet if I go back to my framing plan, there's my beam, and normally a framing plan is coarse level of detail, so that's what you would see on a structural framing plan is just a stick figure for that beam. And it shows it pulled back from the wall, even though when I placed the beam, I placed it all the way into the bearing wall. That's just the little stick figure that you use for a framing plan that pulls back automatically like that. So now what I want to do is go to that building section I created. It called it section 1. But there it is, there's my beam. I'm at fine level of detail, so that's what the beam really looks like. Now I'm going to rename that section before I forget. I'm going to call it transverse looking north through beam. Okay, and I mentioned we're going to do a detail tonight. This is a building section, and a 1/4 inch scale is a reasonable scale for a building section. But rather than playing around with the scale of this building section, we want to be able to say, well, we might want to put this on a sheet and then blow up a detail. So now we're going to do a blow-up detail of that beam to show where it's placed relative to the floor and the column and the level here, first floor level. So, who can tell me which of the ribbon tabs we'd probably go to make an enlargement, a detail view? View, right, because we're creating a new view. and Revit calls it a callout when you're bubbling an enlarged view. So if you hit the callout button, there's a choice of either blowing it up to another building section, a wall section, or a detail. Well, you can toggle between building and wall section, but once you make it a detail, it has to stay a detail. So I'm going to make sure I pick detail up front. And now I can pick what scale the detail will be at. And I'm not sure if I said in the handout here, but let's make it 1.5 inches equals a foot. So that when we bubble this, it'll create a new view at that scale. And so then we just give 2 opposite corners of the little box around that. Once you've placed it, you can grab the little point of the circle and you can drag it around to wherever you want that. And you can also get fancy here and have that little arm kind of stick out at a 90-degree angle like that. So to go to that new view, I double click it. I'm going to close everything else first. Close hidden. Go to that view. There's my detail. 1.5 inch scale. If I tile those 2 views now, you'll notice that once you make a call out of another view, this little bubble here is literally the crop region. So if I make the bubble wider, the detail of crop region is wider. Now, one thing I don't want to see here that I do want to see in the building section is I don't want to see that door beyond because it's not relevant to what I'm doing with this detail. And fortunately, Revit allows you to do that. It's a building section with a detail bubble on it. But if you go into the detail and we look at the various view properties of this, look through the view properties and you'll notice, I'm going to widen this so we can read that stuff. It says crop region visible, annotation crop. Annotation crop means there's a second crop boundary. So if I start putting text in here, if that text is outside of that second crop, it's actually going to disappear until I stretch that annotation crop out to where the text is included. I kind of like it, but I kind of don't, because once the text disappears, you don't even know it's there until you just start fishing around. You can turn off the croppingness, but then it's really confusing. So, you know, I would recommend making your annotation crop nice and big so that it doesn't cut anything off. The idea is that you can put details on a sheet, and then when you're working in the detail, you won't get your text to where it's going to start spilling over on top of another drawing on the same sheet. But it's easier to go ahead and work in the sheet, in my opinion, and we'll see that in assignment J. So anyway, I want to make that view so that I'm not looking deep enough to see what's beyond. I only want to see the column, but not the door and the stone wall beyond. So if you look in the view properties, it says far clip offset, far clip settings. So see how it's looking 43 feet in the distance. If I change the far clip settings, not the same as parent view, because in the parent view I do want to see the wall beyond. In this detail, I want to actually have it independent of the parent view. So I'm going to go down there and say independent. Now I can change the far clip to like maybe 3 feet, so I only see as far as that steel column. And now I don't see everything else that I don't care about. It is, but it's a horizontal view range. It's a good point. Now, if I'm in the plan where that section is cut, there's my section. Notice how I can see that box. So here's really the depth of the parent view. It goes all the way back there, which really I don't even need it to go that far. I could pull it back to here. But that's that 37 feet now. But the cool thing about this is it lets the detail have a shallower depth than the section, the building section it was cut on. So now that I've got my detail, I'm going to go ahead and maximize that on my screen and start playing with it. I've got my column grid, which I like to have in a detail like this. And then I say, okay, I want my beam to be, obviously I don't want the top of steel to be right at the floor level. So you'll see that there's a start and end level offset here. And I want to either drop it down 1.5 inches so that I go below the 3/4 wood and the 3/4 plywood. And that way the beam will be, I'm going to go negative 1.5 inches twice here, both ends of the beam. The advantage again is that hides the depth of the beam up in the floor structure so nobody bumps their head on it. The disadvantage is if I'm the guy building this, I've got to stop all these floor joists on either side, and I've got to put wood blocking in here bolted to the beam so I can put joist hangers on either side of that and hang those joists off the side. So the easier detail and more likely is what they would have built would be to lower that down even further. Now I can just select it and hit the move button and go down to there. And then I want to leave another 1.5 inches so I can put a piece of 2x wood blocking on top of the steel to bear the joists on. So I'm going to hit the move button one more time and say I'll go another 1.5 inches. And now I've got room to put some blocking in there. So here's where we get into something that we're just drawing in a detail only. We're not going to draw this in 3D. And when you do detailing in Revit, you're drawing basically two-dimensional line work and filled regions and even components that are just flat, stuck onto the view. Remember how I said at the beginning of the class, before we did assignment A, when you've got a view, you've got a pretend kind of pane of glass in the view, you've got annotations and detail lines and detailing that's just in that view. Well, in this view, we don't want to actually build the wood blocking in 3 dimensions because you'll never see it in 3D, you don't care to see it. And this is the only detail we're cutting through here. Now, if we were cutting one of these every 4 feet because we had different conditions, then we might want to model that blocking to be continuous. But it's easier just to stick it in this one view. So what we do is we go to, which of the ribbon tabs would you think we would look in for something that's just two-dimensional in the view? There's not one that says detailing, but there's an annotate ribbon tab. So it's really annotation and detailing. So now in the detail panel here, we've got detail lines, which are just 2D lines in the view. We've got regions like filled and masking regions, or we've got detail components. So let's go to detail component. And we've got a few things already loaded in here. Dimension, lumber, and section is what we want, though. So if you go down to the 2x6, there's a component that's just a two-dimensional outline of a 2x6. And as you're placing it, you can hit spacebar to rotate it 90 degrees. And then I'm just going to place it right on top of the beam, and then I'm going to move it over so that the midpoint of that is right at the center line of the beam. Now that really, you shouldn't be able to see the column through that. That's because this is a crappy detail component that came with Revit a few years ago. So I'm just going to delete that and try again. I've got a better one. Let's go down, and you'll find it under Families under Detail Items. Dimension Lumber section. Let's just delete that family. And let's try loading the one out of the 2012 library. So if you go to Insert, Load Family, this is the out-of-the-box detail components. And you'll notice these will stick on two-dimensional things are organized by the CSI Master Format Division. So we want to go to Wood, Division 6. I went to, I'm going to Detail Component, and then I go and Load, and I go to the Detail Components folder in the out-of-the-box. Then I'm going to Division 6 where you find wood and plastic elements. Then I'm going to Wood Framing, and they call it Nominal Cut Lumber section now. It still doesn't have what I'd call good line weights, but if we open that and load it, we can load the 2x6, the 2x4, and 2x8 and 10 in case we need those later. Maybe a 1x4 and a 1x6. It's all the same family. Now, see how that's got a better line weight, and it should actually blot out what's behind it. It should have a masking region inside. So we'll do the 2x6 here. Spacebar to rotate. And that one is masking. So the ugly one was one that had been there since I started the class, and I hadn't purged it out of the template. So we want the better one that finally they got around to cleaning up in the out-of-the-box library. So that detail is showing something. It's only going to show up in that one view. If we go back to our tile with our building section, notice how that little piece of wood blocking doesn't show up in the building section. It only shows up in that detail. Now, if I wanted to show it at this scale, I could select it and do a Control-C to copy. go back to this view and do my same little paste align to current view. But see, at that scale, you barely even tell what it is anyway, so I'm not even going to do that. I'm just going to let the detail speak for itself. And so then I can put that on a sheet when we get into placing views on sheets. And then we've got ourselves a detail. And then I can also turn off the crop region here. So I'm going to go to hide crop region at the bottom. And then if you want this to look even better, well, for one thing, we want the top of the column to be attached to the underside of the beam. I haven't done that yet. Yeah, and so I think it'd be better to go to 3D to do that than in line detail, because I'm only looking at that one. So let's go to 3D, and I've got my section box already on. There's my beam, there's my two columns, and there's the rest of the floor. So I'm just going to go ahead and select both of those columns in my 3D view. And just like we did with walls, you do the attach top base. We're doing the top, so we leave that button the way it is. And then we pick our beam, and it should say select the roof, floor, ceiling, beam, reference plane, whatever you want to attach it to. So then it trims the top of the column to the beam. If we go back to our detail, now that looks like it should look. And then a couple of things I didn't show in the assignment. If you want to show a break line on this detail, go back to annotate detail component, and there's already a break line loaded in here. It's just called break line. And if you spacebar to rotate it, the break line actually obscures what's on one side of it. So it's kind of a cool little detail component. You want to be sure, though, that the jiggy jag doesn't go outside of the crop region, because otherwise it'll actually trim off the jiggy jag part like that. So I'm just using the left and right arrows to nudge it. This is one of those things that you can kind of drag around and nudge, and it doesn't hurt anything because you're not dimensioning to the break line. And then I'm going to take it and use these grips to shorten the legs of it. And then I'm going to use these grips to squash the jiggy jog so that it's a little bit more sharp and dramatic looking. So then once I have one on that side, I can mirror it, pick the axis column grid, and then I can just nudge that over until it shows up in the view right there. And you could put a break line there. I like to have a break line that has like a little pipe cut off, and I think I have one, but I don't think I put it out here on the library. So I'll see about adding that later. It's a better looking Revit content. I don't think it's in here. I don't have detail components, any of them out there. So. But that part right there is the detail. So we've covered everything that's required of assignment E now. Yes? Good point. And that's the other downside of dropping the beam down, is that that door hits the beam and you've got a conflict. And part of the reason I kind of left this in here is because it shows how when you build things in Revit, you're doing more than just drawing a framing plan or a floor plan and an elevation. You're actually resolving things in 3 dimensions. So our building may be a really simple little rectilinear building, but we're looking at it in 3D and we catch things that we wouldn't otherwise catch if we were just drafting it in AutoCAD. So what Charles is pointing out is that if you look at your door and you did the beam down like I did, the beam is kind of nudging its way into the door location. In fact, I'm going to go to my plan. If I extend that grid line and see where it is, did I dimension? I want to go back to the previous assignment handout because I may have put it too close. Assignment handouts D. Yeah, I didn't really show a dimension there, but if you take me literally, the frame of that door is practically right up against there. I can align to there. So if you built it as I drew it in assignment D, beam is going to go through it in 3D pretty clearly. And that's a problem. So then you have to resolve the problem. You either say, oh, I'm going to have them build it with that beam higher, or you can shorten the door and just say, okay, you got to stoop to go through the basement door. And if you notice some of these old homes in the area, the stairs are too steep, the doors may be too narrow, and so I'm going to just go ahead and make a 36 by, I really should have used a 36 by 80 anyway, but I'm going to edit and duplicate, and I'm going to make a 36 by 76, that's 6'4", and see if that's low enough. So I'm going to change the height to, where's my height? 6'4", that's 76 inches. Okay. So because I grabbed that door before I changed it, well, look at that, the door worked, but the casing of the door didn't go down with it. So I've got another door problem. I tell you, Revit is really wanting to haunt me over these doors I built several years ago. I'm going to see if I can fix that real quick here. The door family. The height. Okay, let's look at the interior view. That is a component. Its height is equal to the height. If I try changing that to a 36 by 76. So there's something wrong with my casing family here. Wow. Where's my reference plane here? I made it 6'4", but I'm going to see if I can fix this casing so it works right. I'm going to put a reference plane in here. Yeah, I'm glad I'm recording this. We got some gigglers in the hallway in case you couldn't hear that on the recording. Okay, so I've got a casing offset of 1/4 inch. That's what's going on here. So I'm going to edit the sweep. I'm going to edit the path. I'm going to dimension from there to there. Make that 1/4 inch. Finish. Finish. Make that the height. Load that back in into the door. Go right. And then I'm going to load that back into my project. Okay, so 6'3" will work. So I'm going to rename that to 36 by 75. And change my height to 6'3". So you better not be too tall to go through this basement door. I can handle it. I don't know what's wrong with you tall people. And then I'm going to go ahead and save that out to the library, so if anybody wants to reload that door, I was actually successful in fixing that door, fortunately. Exterior flush. Save that out to the mirror. I'm going to put it in the SLCC-MC, and I'm just going to write over the other one. Cool. And then I'm going to open it real quick before anybody loads it and get rid of that new type I made because I want you to have to create that type. So then I can go in here and I'll just delete that one. I'm going to save, overwrite. Okay, so if you have any trouble with the door frame, the trim looking too tall for the door, just reload it and that should fix that. It's the exterior in-swing single flush with the lintel masonry and brick mold casing. Let me delete the other one. The one with the .0001 is a backup copy. And 0002, there's probably two of them there. So thanks for pointing that out. I will purge that other one. It's the one that says door exterior in-swing single flush lintel masonry brick mold casing.rfa. Yeah, so I deleted the one that had .0001 and 0002 because those were the backups when I saved as I was fixing it. So, where are we here? We've pretty much covered everything that's required, so I'm going to burn this recording. Stop. This is session 5.